Howdy and good day, Algebra. We are continuing through Unit 2. We've talked about expanded form, writing exponent expressions out without an exponent, really showing that repeated multiplication. We talked about coefficients, we talked about bases, we talked about the powers. Now we're going to start to kind of use that to simplify exponent expressions, which is what your next 4 objectives, 5 including CO10, are all going to be about. Different rules for how to simplify exponent expressions. So we'll start with, what does it mean to simplify something in the mathematical context? Yes? You can't break it down anymore, in the sense of a fraction maybe, right? Divide by that greatest common factor to break that fraction down, yeah? To put it in simplest form, yeah. And what are we doing when we do that, Ellen? Okay, I'm going to run with that definition there. Okay, basically, what we're looking to do is combine like terms. Okay, and what we're focusing on here is coefficients and like bases. Coefficients and like bases are what we are going to be really focusing on today. Okay, so to simplify, combine like terms, coefficients, and like bases. You're going to get a little bit annoyed with me at the start of this because I'm going to force you to write all these out in expanded form until we really see and understand and know. At least I'm telling you up front, so you're not surprised. You know, they'd be like you walk into the class, say, "Hey, Schultz, just to let you know, I'm going to talk a lot today. You'll tell me to quiet down, but I'm not going to. So just giving you heads up, I'm really going to get on your nerves." I'm doing the same thing here. I'm telling you, I'm going to annoy you. But anyway, when we really see then what's going on, then we can jump from expanded form into the shortcut, and your lives are going to be easier. Okay. So let's look at these 3 examples here. It says first, write each in expanded form. So 3 to the 4th times 3. That 3 to the 4th, like we looked at yesterday, is going to be like 3 times 3 times 3 times 3. Right? We got 4 3s all being multiplied. And then we're multiplying to that 1 more 3. Okay? So in the end, how many 3s do we have all being multiplied together, Kylie? 5 of them. So how would we write this as one term? Rather than 3 to the 4th times 3, how could we write it as one term, Catherine? 3 to the 5th. Yay, you just simplified an expression. Okay, and hopefully you can see by writing it in expanded form exactly where that 3 to the 5th comes from. Okay, the next one, 7y cubed times y to the 4th. Let's start by writing 7y cubed out first. Crinkle, what is 7y cubed in expanded form?
7 times 7 times 7 and
No.
7 times y.
Yes.
And then I know what to do.
Okay.
You add the two exponents together, and then you add that number of y.
Okay. So what Crinkle's kind of saying here is that with that 7, and again, there's only one 7, that is not part of the exponent. It's a coefficient, not a base. We got 7 times y times y times y. And what she's noticing here, kind of based on the last one, is that this second term, which is y to the 4th, or 4 y's all being multiplied together, she's saying, well, we're going to have a total of 7 y's here. Because the 3 from the first term and then the 4 from that second term, we can see how many y's do we have multiplied together? 7 of them. How many 7's do we have? Just 1. Okay, so our simplified expression is 7y to the 7th. All right, when we write it out, we kind of put it all together, we combine those like bases, all those y's, can be written as just one term and our coefficient out in front. The last one here, 8x squared y squared. What does that look like in expanded form? 8x squared y squared, Jack?
8 times x times x times y times y.
All right. 8x squared y squared is 8, only one of them, times x times y times y. Okay? 2 x's and 2 y's. How about 5x to the 4th y cubed, Aiden?
5 times x times x times
Good. Okay. 1, 5, one coefficient of 5, and then 4 x's, x to the fourth, and then y cubed, 3 y's. Anyone want to take a guess at what this is going to look like now when we simplify it together? Arlene? 40. X to the 6th power, y to the 5th power. You're absolutely right. Okay? You're absolutely right. If we look at this, where does that 40 come from there? Well, it comes from our coefficients 8 and 5. Why wouldn't we add those? Because Crinkle said earlier, you add the powers. That's how she got 7 y to the 7th. Why wouldn't we have 13? Go Max this time. Max.
Because in between every single one, you're multiplying, so it would be 8 times 5 instead of 8.
Yeah, and if you heard the commutative property before, that says you can multiply things in any order. So even though our 8 and 5 aren't next to each other, because there's only multiplication going on in there, right? We can combine them to get 40, 8 times 5. And then x to the 6th, where'd that come from? Kylie? Sure, we have 2 x's here, 4 x's here. Total, that gives us 6. We're noticing that we got 2 plus 4, that equals 6. And how about the y to the 5th? Where did that come from? Jack?
There's 2 y's there and then 3 y's there.
Yep, y squared, y cubed, 2 plus 3 gives us 5. I think we're on to something here, folks. Okay. This type of calculation is called multiplying by the same base. Okay. And you know that you're going to be multiplying by the same base because look what we're doing. We see the multiplication symbol there. Okay. And in this rule, let's summarize it in a key point so we can go on a help sheet here. What do we do with our coefficients when multiplying by the same base? There's only that third one really shows this rule really well. But Ellen? Yes, coefficients are multiplied. As we saw in the third one, 8 times 5. In the second one, what's the coefficient to that y to the 4th? Even though it's not written. Jack? Do you have something else? Or what's the coefficient in this second one here? What's the coefficient to that y to the 4th term? 1, right? So the rule still checks out here. 7 times 1, is still 7. The coefficient got our answer. Wait a minute. Coefficients are multiplied. Why isn't this 9 to the 5th here? Why shouldn't that be 9 to the 5th, Crinkle?
Because it's like the same. If you have the same of one number, it's basically just multiplying by 3. So that's basically adding another exponent.
Yeah, but if our rule is the coefficients are multiplied, why wouldn't we multiply 3 and 3?
You are multiplying.
No, I didn't. I kept the 3 the same. I didn't. 3 times 3 is 9. If we multiply the coefficients, why isn't it 9, Anthony?
Because next to that 3, there's technically a 1 as an exponent.
Say that another way. The 3 is not a coefficient, right? The 3 is not a coefficient. It is a base. It is so important. This one is the one that's going to get you on the test. I promise you. Okay? There will be people who will write 9 to the 5th because they think that 3 is a coefficient. It is not. Okay? In that case, it is a base. Right? So yes, the coefficients are multiplied, but the bases stay the same. We're skipping exponents right now, and we're going down to bases. The base stays the same. Okay? And my kind of proof to you for why this stays at 3 is that when we write it out in expanded form, I don't see any 9s anywhere. What do I see? I see 5 3s all being multiplied together, not 5 9s, right? So that's why we're starting with expanded form so that you can kind of see, oh, yeah, I wouldn't multiply those. A, they're not coefficients, and B, in expanded form, it's clear to see how many 3s I have, right? 3 to the 5th. And then what was our rule for the exponents? What was our rule for the exponents, Max? You add them. Okay? So coefficients multiplied, exponents added, the base will stay the same. Nifty, isn't it?
Fun.
Nice little rule. Throw on a help sheet. It's a key point. We're good to go. Questions on any of this before I erase it and move on? Yes. It stays the same because it's not a coefficient. It stays the same because it is a base. Really, what is the exponent of that second 3 there? It's not written, but it's a 1. So it still follows the rule. There are no coefficients to multiply. The exponents get added. 4 plus 1 is 5, and the base stays the same. Okay? Anything else? Okay. The rest of this page, the directions are for you to write it in expanded form, but at least I told you that I would annoy you with this. Okay, so you can't be mad at me. But after this page, starting with the second page, then for this rule, you will no longer need to write it in expanded form. Okay, so I need to see the expanded form here, but not going further. What one would you like to see? What do you want to do together here, Claire? The last one. I'll be happy to clarify that one for you. So 1/2 a to the 5th times 200a squared. First of all, let's write this in expanded form. 1/2 times a times a times a times a times a. There's our first term, right? 1/2 a to the 5th times 200 times a times a. There's our second term, 200a squared. Again, expanded form is required for this first page. If you don't have it written out in expanded form tomorrow, you will not get credit for completing the homework. So make sure you do it for this first page. Yes. Vince, Joey, boys, if you'd like to continue this argument on the hallway, then you may do that, but it's not going to happen here. Yes. Well, hold on. We're still on this one. Okay. So now that it's in expanded form, you look for: do I have any coefficients? What do I do with them? What are my bases? Okay. And then how many of that base do I have? So coefficients, we've got 1/2 and 200. Those get multiplied. What's 1/2 times 200? Or, because our brains think better this way, 1/2 of 100. Alexis? Did I say 100? I meant 1/2 of 200. 1/2 of 200 is 100. Okay? So the coefficient on our answer is going to be 100. Coefficients get multiplied. That base of A isn't going to change. We're still going to have a base of A, and how many do we have? Total of 7. We see that, right? I can literally count them: 1, 2, 3, 4, 5, 6, 7. Or, using our rule, our exponents, 5 plus 2 gives us 7. Okay? Yes, sir? I'll go to Beckman first, because he was going to take us someplace else. Negative 3x cubed times 9x to the 4th. We'll start by writing this out in expanded form. Yes.
If you do, since the 3x to the power is negative, will you do 3 minus 4? Or you just still add it?
No. So that's a good question, because we will come across negative exponents, but not in this case. So that negative sign belongs to the coefficient, right? So when we write this in expanded form, it's just negative 3 as our coefficient times x times x times x, and then times our other coefficient 9 times x times x times x times x. Okay? So that negative sign only affects that coefficient. So when we do go to our rule now, and we multiply those coefficients together, it's going to make our final coefficients negative, right? Negative 3 times 9 would give us negative 27. Okay? So it does not affect the power. Our powers are still added. 3 plus 4. We can count up the x's. We have a total of 7. Okay? Question on this one?
Not on this one, but I have a question about everything.
Ooh, yes.
Are we allowed to use a calculator?
You will be able to use a calculator on this test. It's going to only really be helpful in your work with the coefficients, because the exponents, you can't really, I'm not going to tell you how to put those in your calculator. But, so yeah. Long John, what was your contribution? Last one, first row, 7ny squared times 2n squared. Crinkle, do you have a question about this one first?
I have a my order?
No. So the rules for how to order variables, if you've got multiple of them, standard form would be the greatest to least exponent. So if you have like an a squared and an x to the fifth, you wouldn't put the a first because it's alphabetical. You put the x to the fifth first because the power is higher. But then there are some folks that just prefer alphabetical. It really doesn't matter, in the end. I'm not going to split hairs over it because we're not talking about standard form for that. So don't worry about it.
So if, like, we don't put it in the right order, you won't on the test?
I'm not going to say there's a right order for it for the test. Okay? Probably some math teacher out there watching this, you're like, curse that man! You must put it in the right. Anyway, okay. Don't forget to like and subscribe. All right. So for this one, we've got 7. We've got a base of n and a base of y. 1n and 2y. So that's what 7ny squared looks like written out. Then we've got our 2n squared, which is 2 times n. What's this going to be when we simplify it? What's this going to be? Claire? Yes.
7 or 14 n cubed and then y squared.
Good. 7 times 2, those coefficients get multiplied to give us 14. We have a total of 3 n's there, n cubed. And we have a total of 2 y's for y squared. We can't combine n and y because they're not like bases. We couldn't put like ny to the fifth or something like that. Okay? Different bases got to be kept separate. Vince, you with me? Good. Remember that n has an invisible exponent of 1. Okay? Sometimes when folks go away from expanded form, they forget that, and they just put n squared as an answer. That is a 1n. So you need to add 1 and 2 to get that n cubed there. Yes, Alex?
Oh, on the very last question.
Yes.
On the last page.
Oh, we're not there yet.
Oh.
Other questions on this first page? Sir?
The second row and the third one, since it.
Okay, happy to help. Anything else? Okay, your homework then. By the way, did anyone put down for an answer 100 to the 5th power?
I put 5 to the.
Hmm?
I mean 10.
Oh, okay, good. Right, those 10s are not coefficients. Those 10s are bases. They stay the same. 10 to the 5th power, which when you write it in expanded form, you should clearly say that, right? There's no hundreds anywhere. It's all 10s. Question on this page, or you want to go to the next one? Yeah.
So let's say it kind of looks like 105, but it's supposed to be 10 to the 5th.
If it kind of looks like 100 to the 5th power to me on a test, I will kind of mark it wrong.
No, it looks like 105. Like.
Oh, you're writing all sloppily. So you're writing it kind of like that.
Yeah.
Oh, yeah. Since we're dealing with exponents, I'll know that you mean that to be an exponent, but that's a bad habit to get into. Yeah. Take it from the neatest writer that you know, me. Yeah. Okay. Your homework is to finish this first page. You do need to write these in expanded form first. Then the second page is homework as well. Notice that the goal here is to not have to write the expression in expanded form. If you need to, you may. But we want to move away from that and start to use the rule that exponents added, coefficients multiplied. So this second page, I don't need to see the expanded form, but I do need the answer. Any of these 12, it looks like, that you want to talk about before we, Alex? The last one. What's your question on it? Can what be negative? Oh, you're talking about the bottom one?
Yeah.
Oh, so this very bottom section here, it says you need to fill in the missing powers, basically kind of, understanding how do we get to, for example, n to the 9th here, right? How do we get there? We have 8 of them, We've got 5 of them. We need to end up with 9 of them. I did kind of use some, oh, here's a lit connection, foreshadowing that we would come across negative exponents. As Alex is pointing out here, if we already have 8 ends and we're getting 5 more, but we have to end with 9, we're going to have to kind of go backwards, right? 8 plus 5 is 13. How do we get from 13 to 9? Subtract 4. So yes, this would be n to the negative 4th power. Beckman brought up earlier about subtracting when you've got negatives. It doesn't happen with a negative coefficient. It would happen if you've got a negative exponent. 8 minus 4 is 4, plus 5 gives us 9. Okay? So negative exponents do exist, and that is a situation when you'd have one. Anything else? Other questions, comments, concerns, complaints, comments, congratulations, or criticisms? Yep, Beckman. You may not. You got all your social time when I was trying to quiet you down earlier. Aiden.
I have a compliment. You're a great math teacher.
Aw, shucks. Thanks. You're a great math student. Okay, homework for Monday, actually, because we have a retake day tomorrow. Don't forget, Khan Academy is due tonight. If you have not finished that yet, get on it. Football sheet is due tonight as well. If you've not done that yet, get on it. The football sheet is optional for this coming week. Yes, week 6. Yes, the first game's tonight, Thursday. All right, that's our math.